everybody. Today we're going to learn how to factor using a grouping method. There's lots of ways to factor. This is just one option for you to use. Before you start any kind of factoring of a trinomial or anything, you always want to look to see if there's a greatest common factor that you can divide all the terms by, because that'll make your problem so much more simple. So I am first going to see if I can take a greatest common factor out. We shorten that to be a GCF. I notice that I can divide 9, 6, and 24 by 3, which means it has a greatest common factor of 3. So I'm going to divide each term by 3, 9x squared divided by 3x, and I'm left, or 3, and I'm left with 3x squared. Negative 6x divided by 3, and I'm left with negative 2x. Negative 24 divided by 3, and I'm left with negative 8. Now, all I have left is to factor this trinomial, which is much smaller numbers and easier to work with. The first thing we want to do is we want to brainstorm what are two numbers that multiply. We are going to multiply the a times the c. The a is whatever's in front of the x squared, the b is in what is ever in front of the x, and the c is the numbers here at the end. So I'm going to multiply the a times the c, which gives me negative 24. And then the b is negative 2. So what I want to brainstorm here is numbers that multiply to negative 24 and add to negative 2. So let's think of what multiplies up 24. Well, we've got 1 times 24, 2 times 12, 3 times 8, 4 times 6. That's pretty much all of our combinations. Now we know one of them is going to have to be negative because it's multiplying to a negative 24. So when we look at these two numbers, if I make this 6 negative, it will add to negative 2. Negative 6 times 4 is negative 24. 4 plus negative 6 is negative 2. So we found our two numbers that work. So that's the first thing you will always want to do, is find those two numbers. Because we are going to use those two numbers to split this middle term. We're going to take negative 2x and split it into 4x and negative 6x. The other two terms we're just going to bring down, 3x squared and the minus 8. This 3 is just going to remain outside. I'm just going to bring it down in the end, but mostly what I'm focusing on is factoring this piece right now. But this 3 will be a part of my solution. We're just going to hold on to it for just the moment. Okay, so now that we have 4 terms here, I'm going to look at the first 2 terms and see what greatest common factor that they have in common. Well, 3 and 4 don't have any numbers in common, but they both have one x in common. So I can take an x out of both of these, and then on this one I'm left with, if I do 3x squared divided by x, I'm left with 3x. 4x divided by x, and I'm left with 4. So that is the first 2 terms, GCF. Now I'm going to look at the second 2 terms. Out of these 2 terms, when I look at the numbers, I can divide them both by 2. Negative 6x divided by negative 2, and I'm left with 3x. Negative 8 divided by negative 2, and I'm left with a positive 4. If you notice, both of them have the same factor after we factor those out, which means I can factor out a 3x plus 4 out of both of them, and I'm left with x minus 2, x minus 2 for my other factor. Don't forget this 3 that we took out at the beginning. That is a part of my factors. So if you are just trying to get the factors, these are the 2 factors. Factoring is useful for many different things. One thing it can be used for is to find the solutions of a quadratic. If you would graph the parabola, and if you are looking for these solutions, if you factor it, then you can set each of your parentheses equal to 0. So my first factor was 3x plus 4. If I set it equal to 0, I would solve for x, and I would find one solution is at -4/3. That would be over here somewhere. And then I would take my second factor, x minus 2, set that equal to 0. And that would be my second factor. Notice for the factors, we ignore the greatest common factor. This does not tell us where a solution is. Only the two with the x's tell us where a solution are. So that is one way that you can use factoring, is to help you find the solutions of where it's crossing the x-axis. Remember, we can call those 2 points, we can call them solutions, we can call them roots, they can be called x-intercepts, but they can be called zeros. All 4 of those words mean the exact same thing. So that's one way that factoring can be used. All right, let's try one more example and make sure we got the hang of this. So remember, the first thing we're looking for is a greatest common factor. Can we divide all 3 terms by one number? In this case, we can divide them all by 4. So if I divide them all by 4, I will create a new trinomial to factor. 24x squared divided by 4 is 6x squared. 4x divided by 4 just leaves us with the x, because 4 divided by 4 is 1. Negative 48 divided by 4 is negative 12. So now we have a new, much smaller numbers to work with to factor from here on out. So to find how we're going to split this middle term is we are going to brainstorm what numbers, and if I multiply 6 times negative 12, I get negative 72 and adds to 1. So we're going to get 9 and 8, multiply it to 72, and we want to make the 8 negative so that it adds to a positive 1. So we're going to split up this x into be 9x and negative 8x. We're going to bring down our 6x squared and our minus 12. Remember, our greatest common factor we're going to carry down as parts of our solution later on. So I'm going to look at the first 2 terms, and I'm going to look to see what I could divide both of those by. What is the greatest common factor of 6x squared and 9x? Well, I could divide them both by 3, and they both have one x in common. So let's divide 3x into both of those and see what's left. 6x squared divided by 3x, and I'm left with 2x. 9x divided by 3x, and I'm left with 3. All right, let's look at the other 2 factors, the other 2 terms. I can divide a 4 into both of these. Also notice, if this is a negative, always divide by that negative number. It'll help you factor out to make sure that these match in the end, which is your goal. So pay attention to this sign. This sign will always match. So I'm going to take a negative 4 out. Negative 8x divided by negative 4, and I'm left with 2x. Negative 12 divided by negative 4, and I'm left with a plus 3. Notice that helped our factors be the same in the parentheses. So one of my factors is 2x plus 3. My other factor is what is going to be left outside the parentheses, which is 3x minus 4. Don't forget to count your GCF as part of your factors. If it asks for a factored form of the polynomial, this is what they're looking for. These are the factors. One step farther is if you want to find the solutions of that quadratic, remember you can set your parentheses equal to 0. So one solution will be after I set that equal to 0. If I subtract 3 and divide by 2, it'll be negative 3 halves. The second solution is after I set 3x minus 4 equal to 0. So I add 4, divide by 3, I'm left with positive 4/3. Those are my 2 solutions. Or we could call them roots, or x-intercepts, or zeros. Those are all words that mean the same thing for those 2 points right there. We also could write it as an ordered pair, because this is the point where it's crossing the x-axis. 4/3 0 is the point where it is crossing the x-axis at. And that's it for factoring by grouping. Factoring just takes tons of practice, but it is so useful in many ways, and you're going to use it in algebra and pre-cal and calculus and on and on and on. So be sure you practice this as a skill you're really going to need.